In question 16, we've got a circle and a semicircle to sketch on the same axis. So this really just tests whether you know the formula of a circle, which is that x squared plus y squared is equal to r squared. Now you might look at 7 and think that's not a square number, but if r squared is 7, then r can be the square root of 7. Anything's a square number, it's itself square rooted, squared. So that tells me that to draw this I need to have a circle with its centre at the origin, and it's going through root 7, minus root 7 and minus root 7. That's quite straightforward. Next we need to recognise that this is in fact a semicircle here, and it's the top half. How can I tell it's the top half? Well, here y has to be positive because the square root of anything is positive. It hasn't got a plus or a minus out the front here. Now if you forget what a semicircle looks like, then if I square both sides here, then I'd actually have this. I just wouldn't have a square root over this side, and the other side would have to be squared. And if I rearranged it, it looks a lot more like a circle now. But I've done something to fiddle with it. This looks like a circle with a radius of 2, because 4 would be r squared, so r must be 2. But in fact, it's not the whole circle. I've sort of cheated by squaring it. This is only the top half of the circle. It's only the part where y is positive. So I can go ahead and just do the top half of that circle with radius 2 and centre at the origin. In question 17, I need to sketch a cubic curve, and I've been given it in factored form. So if I let y equal 0, I'll be able to find the x-intercepts. Now you can write out 0 equals all of that, or you can just reason, hey, if that was 0, how would I get it? Well, one of these things I'm multiplying must have been 0. Now for this part to be 0, x would have to be minus 2. For this part, 1. And for this part, 4. So that gives me my x-intercepts nice and easily, and I can go straight ahead and plot those as dots. The next step is to say, well, I know what cubic curves look like. They're either like this if they're positive, or they're like that if they're negative. They either go from low to high or high to low. How can I tell what I've got here? Well, the number out the front here is notionally 1, but it's not negative 1, it's a positive. And that tells me I have a positive 1 that must go from low to high. So straight away I can just graph in some wiggly line like this. Don't worry too much if the shape isn't perfect. Mathematically it's got the right shape going on. The only thing that's left to find then is the y-intercept. We find that by letting x equal 0. So sub 0 in here, here and here, and you'll have y equaling 2 times minus 1 times minus 4, and that gives you 8. And then your sketch is complete. Now for B it says, we're asking this round the other way now. Find the equation that describes this cubic curve, and we're just given the curve itself. Now start with the x-intercepts. If we've got those and we go ahead and put it into that form, A, x minus alpha, x minus beta, x minus gamma, where alpha, beta and gamma are these intercepts, then effectively we've got x minus minus 4, and that gives me x plus 4. We've got x minus minus 2, and that gives me x plus 2. And we've got x minus 2. So that gives me this line, and in fact this is the formula for a whole family of cubic curves that are positive, like this one is, it's going from low to high, and have their intercepts in these places. But you need a clue to figure out which member of the family it is that we're looking for. And our clue is this point down here. This clue says that when x is 0, y is negative 3. So you can sub those values in. So here I've written sub in x equals 0 and y equals negative 3 to find a. Alright, so instead of writing y, write negative 3. A we don't know, so just write it down. And we're subbing in x equals 0, which gives us 4, 2 and minus 2. We need to multiply all them together, we get minus 16. And then dividing both sides by negative 16, a must be 3/16. Notice here we've got negatives on both sides, so they cancel each other out. So now I can rewrite this formula that I had, but put the a value in that I've just found. And the last question here, question 18, wants me to classify these graphs as many to one, one to one, and so on. Now start with the ones you know for the question like this, and you might be left with the ones that you weren't so sure about. Hopefully you can recognise that this is a straight line that goes through the origin. And so it's 1 to 1 because each x value only has one y value. So it passes the horizontal line test and the vertical line test, that those lines only go through at once. So that one's an easy one to start with. Next, we've got y equals x squared, and that's your basic parabola that's upright and goes through the origin like this. Now, it passes the vertical line test, so it is a function, but it fails a horizontal line test because that's going to cut through it twice. So thinking through what you've got here, well, when it fails that test, what we're saying is that one y value, whatever this y value is, has two x values that it's associated with. Now, with these descriptions, think x first, then y. So what we've got is we've got two x values that have the same y value, and that's many x's to one y. So it's many to one. The next one's a parabola on its side, so it's actually the opposite way around. Instead of being many to one, it's one to many. And the last one is a circle. It fails the vertical line and the horizontal line test, so it's many to many.